Hi, it's Ms. Reese, and I'm going to be going over page 12, and this is in your Unit 5, Part 2 packet, their Inequalities unit. So what we want to do when looking at each of these problems here, when we're graphing, it might be helpful to look at your toolkit, but the first thing we want to do is for each of these, so like this first inequality here, we want to identify, okay, how would we graph it? So the first thing is we would graph our y-intercept. Our y-intercept is at 0, 5. Our b value is 5. And we know our slope, our m, is -2. That would be like -2/1. We also know that because it is a greater than symbol, the shading for that would be above the line, and it would be dashed, above and dashed. So a few different things we need to figure out before graphing each of these. So then what we could do when we're going to graph it, we're going to put our first point at 0, 1, 2, 3, 4, 5. And so when you're graphing it, I need to be able to see where your points are. So not just draw a line, let's see where your actual like y-intercept is. And you should have another point down 2 to the right 1. And you should actually put as many points on the graph as you can, because it makes your line more accurate. So I'm going all the way on the graph and showing all the points on the graph that I can. Okay, now our other inequality we have here, we have our b value of -3, which means we have a y-intercept of 0, -3. Our slope is the coefficient of x, which is going to be 1 in this case, because there's no number here. We can imagine that there's a 1. That would be like 1/1, and that's positive. This is a less than or equal to symbol, so this would be a solid line. Everything on that line is included, and less than means it is shaded below the line. So we'll start at 0, -3. We'll place our point there, and then we can go up 1 to the right 1, and we can continue that all the way through the graph here. All right, now I'm going to use my line tool. I'm going to do a solid line here. And then I'm not going to use the line tool for the other one. I'm just going to use those dots. You can maybe add in some dashes, but we know that's a dashed line. And then what we have to do is we have to add shading to this. Okay, so I'm going to add shading. I'll add pink shading for this one. So the shading for our first line was above the line. So this would be above the line. If I were to pick any point on this line and go up from that point, this would be the shaded region. And the shading for our other line, here's our other line, would be below. So the shading for that is all going to be down here below. Now, the solution to this would be where there's shading in both regions. Okay, so essentially, this part on top here has pink shading only. This one here is blue shading, and we want the overlap. So this would be almost like creating purple here. This would be the solution area. So anything that's in this solution area or in this purple region, that would be part of the solution. Anything that's on the solid line would be part of the solution, but not if it's on a dashed line. Okay, so question 2, you're going to do the same exact thing. So figure out where your intercepts are, use your slope to graph more points, and then you're going to be shading these and deciding if they're solid or dashed and where the shading is located. Now, starting on question 3, I need to see your work for converting these into slope-intercept form. So we've got 5x minus 6y is greater than 42. So we need to write this in y equals mx plus b format. We could subtract a 5x on both sides, and that would leave us with -6y is greater than -5x plus 42. I would divide by -6 on all of the terms here. And that would be, now because we're dividing by negative, remember our inequality flips. And that's going to be negative divided by negative, which is positive. And then 42 divided by -6, which is -7. So for this question here, I should see the work for converting it. And for this other part, we've got the 3x plus 2y is less than or equal to 14. We're going to convert that as well. So subtract the 3x on both sides, similar to what we did here. That would give us 2y is less than or equal to negative 3x plus 14. I'm going to divide everything by 2. And that would give us y is less than or equal to negative 3 over 2x plus 7. Okay, so now that you have your two inequalities, you should be able to take both of these and graph them here. For question 4, you're going to have to convert both of them. Question 5, you're going to have to convert the first one. And then remember, the x is greater than or equal to negative 6. That's a vertical line. Vertical through positive 6, rather. So we can do that one together. So 1, 2, 3, 4, 5, 6. And it's going to be solid line that goes through that vertically. And that's because any point that exists that's on that line is part of that solution. It's 6 or greater. Okay. It's kind of just like what we did when we were graphing inequalities on a number line. Like, let's say I had 6, I had 7, I had 8, or 5 below that, rather. We would do a closed circle and it would face to the right. Well, it's the same thing here, the same idea, but it's instead of a closed circle, we call it a solid line. And instead of kind of an arrow pointing to the right, it's just shading to the right. So we don't have like really shading for above or below. So this would be this inequality here. Then you would need to rewrite this other one. We've got x minus y is greater than 3 to graph that on there as well. So subtract an x on both sides. Negative y is greater than negative x plus 3. And then you would divide everything by negative 1. And a reminder, when we're dividing by negative, you are going to flip this inequality. Negative divided by negative, positive. Positive, negative will be a negative. So now you should be able to graph this on here as well, shade it, and then figure out where the overlapped shading is. And on question 6, this one is ready to graph. It's in slope-intercept form, but you will need to rewrite this inequality here.